Hold on. You're on.
Good evening, everyone, and welcome to Cornerstone Home Inspection Education Center. Tonight's speaker, David Cofske from P&M Sales, and he's also works with Leviton. He's going to talk about GFIs, and I think we're going to mix a little artful in there too as well, and some of the history of those, and how they work, how do you test them, and I'll turn it over to Dave.
Good evening, everybody. Thanks for having me. See if I can, a little bit about P&M Sales. We're an agency located in South Windsor, Connecticut. We basically cover the 6 New England states, and we sell to electrical distributors and contractors in the market. And over the years, we've won many sales awards for our performance with our principals, which from what you can see is, I represent 3, 6, 9, 11 lines in the market. So actually have some, lines maybe down the road. If another area has some interest, I'd be more than happy to come back and talk to you guys about that. Basically, I'm going to be talking about GFCI, AFCI, and I was going to kind of roll in some of the things that are driving those items in the houses, residential houses, and some of the buildings that the products are actually designed to go into. So within the National Electrical Code under Article 210, that basically really talks about, branch circuits. And that's really talking about, GFCIs, receptacles, AFCIs. Where are they used? What do they actually do? And then I guess, why do I have to use them? So moving real quickly into what a ground fault is. So a GFCI stands for a ground fault circuit interrupter, and basically what a ground fault circuit interrupter does is it's measuring the current between that's coming into the device and going out, and monitoring that for a difference in current. And it's basically GFCIs are a UL 943A device. A is an apple, and those are all required to be at 5 milliamp trip to basically protect people. So as soon as the device sees a difference from the incoming and the outgoing current to ground, it basically will open up and trip. And basically that's what it is intended to do. It's a safety device, and it's to protect against shock. The bottom right illustration basically kind of shows a diagram coming out of your load center. You can basically in a circuit, so a circuit's a wire coming out. As long as you lead with the GFCI on the circuit, you can protect other devices downstream for ground fault circuit, protection. So, and the code basically says that there's really no limit on how many receptacles that you can have after the GFCI, but typically electricians will they basically kind of set a limit. I've seen it like 5, 6 receptacles, and then they kind of call it quits. The GFCI has been around for a long time. They came out in the 60s. I think, from this chart, you can kind of see, they started becoming code driven and basically, I guess, tracked through time. So basically this chart really just shows that as the number of GFCIs increased, I guess in the United States, North America, electrocutions have come down. So I guess the purpose of them is they're doing what they were intended, to do. Shifting gears, I wanted to talk about AFCI and basically, how does an AFCI work? So an AFCI is kind of totally different. It's looking for damaged wire. It's looking for a potential arc in a wire. And it basically, instead of traditionally what would happen is, you get heat, you get arcing going on, you could potentially have a fire. Basically, an AFCI would open up and trip when it detects several things. It would, if it detected a parallel arc, where you can basically see that diagram, a series arc, or it can actually detect a cord that's being plugged into the device. So if a vacuum was plugged into an AFCI or any other type of an appliance and the cord is actually damaged, the AFCI device will see that and basically open up and prevent any type of, spark or fire from starting. So that's basically what an AFCI does. When you're talking about AFCIs in the device form, like a receptacle, I included this list of, this is basically how you have to run an AFCI device in a home. You come out of your panel and you basically need to come out of that metal enclosure with either a piece of rigid, that RMC's rigid metal conduit, intermediate metal conduit, EMT, electrical metal conduit, or a cable, like a metal clad steel armored cable from that panel to the AFCI device. And that needs to be, bonded. And then after that, you can basically run Romex, which is a non-metallic, conductor. It's really the only way for that AFCI device to effectively work. Now we kind of get into, okay, so in a home, where do I use GFCIs and where do I use AFCIs? And basically the code says today, AFCIs are the top greens, the right top green section. In all those rooms, they need to be protected AFCI under the code. And the bottom right, the blue section, those areas need to have GFCI protection. When you slide up and you see the kitchen and laundry room highlighted in red, those devices or those areas in a home need to be AFCI and GFCI protected. So kitchens and laundry rooms need to have both AFCI and GFCI protection by the code.
Dave, that would be a combination, right? Type breaker.
Yeah. So in the breaker world, that would be known as a combination breaker or a dual function breaker. Absolutely. Yep.
Is there a way for us to tell, just looking in the panel, the difference between ARC, GFI, and combos? Is there something that,
usually the manufacturers of the panels and the breakers do a pretty good job at marking those breakers on the outside. So when you look at them, you can I guess identify the difference between the breakers. We as Leviton, we manufacture a load center on the panel as well. I've got some slides later on in the presentation, and you'll get a feel of how we mark the breakers based on AFCI, GFCI, or dual function.
David, so, when were these first required? What do you know the year?
So GFCIs were probably the first, and they probably go back to the maybe the early 80s, I'm guessing. Okay. So they've been around for a long time, the GFCIs. GFCIs, and I think I got a slide coming. Let's see if it's coming up next. Yeah. GFCIs, for the most part, were a test and reset type of device. So when you used to buy these and install them, they used to come with some instructions. And I guess we know how people like reading instructions or taking direction. We don't do it very well. Those devices never got tested. The only time it ever got tested was when it tripped. Someone would reset it, and if it would hold, life went on. But I put a date up there back on June 29th, 2015. The NEC and NFPA basically said we want a device that's basically self-test. So from that date, no manufacturer could manufacture a GFCI device that wasn't self-test. So anything that's out there installed in the house right now, or was available to buy in a store, was grandfathered in, and you could install those in a residential house. But after 6/29/15, all devices are self-test. And basically what self-test, you can kind of read the bullet points. As soon as you power up, within 5 seconds, it goes through a self-test to make sure that there's GFCI protection in the device. And then basically every 15 minutes, it basically goes through a cycle and rechecks. And let's see if we get to the next one. On our devices, we have an LED down at the bottom right of the device. When it's on green, it basically is telling you that the device is operating as designed and it is working well. If you lose power in the house, the light goes off, obviously. But as the power comes back on, you go through that self-test. It should go to green. If we have a GFCI short, it's basically going to trip, and you'll either get a solid or a blinking light. If you try to reset it and it stays into that red mode, it's basically telling you that the device is at end of life and it needs to be replaced. What's unique about our GFCI devices, as soon as it gets into a no power or a red light, it basically cuts power off to the face of the receptacle. So it doesn't allow any power to come through the prongs of the device. So again, a safety feature that we built into to this generation of GFCI device.
Dave, two questions. What is the life cycle of a GFI outlet?
I mean, there's no given, but it can last up to 20, 25 years.
Okay. And the second question we have here is, someone's seeing problems with an AFCI, GFCI issues with microwaves. They've had 2 microwave circuits trip when the microwave door was opened and closed while running.
Yeah. I'll get to a section kind of talking about that, but yeah, I'm going to talk about what I'm seeing and what Leviton's seeing as a company with the introduction and the enforcement of AFCI and GFCI, and I'll get into that issue that was brought up below.
Perfect, thank you.
Excellent. A couple just code articles that I felt were important to bring up, because I know you guys are inspecting houses. This is like new code coming in, but it's things to be aware of, because the requirement for GFCI and AFCI mostly was 120 volt circuits, like 15, 20 amp circuits, and they were mostly device and device, device and receptacle loads. But under this article 210.8, it has expanded, and it's basically bringing in 240 volt circuits into the mix that need to be protected by GFCI GFCI protection. Let's put it that way, because the one thing that I'll bring up, nobody at this time makes a 240 volt receptacle that's GFCI protected. The only way you're able to protect that circuit is through a circuit breaker, so through a 2-pole GFCI circuit breaker. So basically what this article is talking about is these 250 volt circuits, your stove, your electric range in your kitchen now needs to be AFCI and GFCI protected.
Wow.
This little illustration of, just GFCIs, typically at the counter, I think the code was like anything within, 6 feet needed to be, GFCI protected. But as you can see, garbage disposals are now under that 210.8. So those are the things that, I guess, as you guys are inspecting and looking at things, there's a lot of properties out there that are grandfathered in because they were built at a certain time. They were built to code at that time. And as long as you don't touch the wiring within that property, you don't have to upgrade to bring it up to code. But as soon as if you went into to demo a room and, take down a wall or do something, you've just opened it up and now you're forced to have to bring that residence up to standard code. So
we always call it a safety thing, Dave. Like I was saying before,
absolutely.
And we suggest it, but
nobody likes to hear, the government's telling me I got to do what? This other 210.8 section basically is adding, if there's some type of an island, or they refer here to a buffet as well. Those areas need to have GFCI protection under the current code. This kind of goes into that the same 210.8 section D, and some of it's in areas that are not residential, but it basically, I think from like 6 down, it gets into some of the residential stuff, such as sump pumps, dishwashers, electric ranges, wall-mounted ovens, counter-mounted burners, clothes dryers, and microwaves. All that stuff now is required on GFCI. Garages need to be, basements, garages need to be GFCI protected. This article just talks about if you have a GFCI device in your garage, you can use it. You can come out of your garage for an outdoor receptacle, but you just can't run that circuit anywhere else other than to a receptacle on the outside of the house. This one here actually gets into on 210.52, and it talks about receptacles, and they don't have to be installed at the time of like if there was a peninsula going into the kitchen. You don't have to have a receptacle there, but the electrician needs to wire for any future addition of somebody putting a receptacle on a peninsular island. So when you go into a house, if you see a peninsula and it's a fairly new house and you don't see a receptacle on a counter, there should be some wiring underneath if they did it to code to be able to easily add a receptacle up on the peninsular counter. And I guess that's kind of a little diagram of what that code requirement's talking about. So over down at the bottom, you can see where there's a receptacle on the top, but it doesn't. The code's basically saying you don't have to install it. You just need to have provisions of the electricity or a circuit being brought into that island so that you can add a device. And this is kind of our current flavor of GFCI devices that we manufacture. starting over to the left, this is your typical GFCI device. They were made in 15 and 20 amp, and they make them in tamper resistant and non-tamper resistant. If you guys are aware of tamper resistance, is basically little doors on the devices to prevent kids from sticking things in there and getting a shock of their life. In residential applications, tamper resistant receptacles are the code. So you'll see them in houses because they've been there for a long time. They don't need to be upgraded unless you do something. Then you're going to be forced to, bring your whole house up to code. Anything going into a residential application, and it's basically the height off the floor, but those receptacles fall within that height requirement, so they must be tamper resistant. The next one is basically a weather resistant GFCI for outdoors. You can basically see down in the left hand corner there's a logo WR. Any device going outside needs to have that WR symbol on it. If there's an inspector that's going to inspect the property and he doesn't see that WR symbol, he's going to basically make you pull it out and put one in.
Dave, does that go for ones like I use my house, for example. I actually cut a hole in my siding and recessed. They have those recess boxes, so it's now inside the wall cavity. Yep. Does that apply for that as well? Like everybody has a GFI sticking out on the outside and all that.
Yes.
So you have to go with the WR on those, on any one.
You do.
Okay.
Yep. And just some footnotes below our weather resistance. We basically use stainless steel straps on the device, stainless steel screws. It's UV thermoplastic protected, so it won't change colors for you, and it's impact resistant for cold environments. So our WR devices really stand up to the environments. They're built to last. We make a blank face GFCI. So this is something that is used a lot in retrofit applications. Somebody will install a bath fan. Somebody will install something in the bathroom, and it's not GFCI protected. This is an easy way to, mount this into a box and, run your wire up to whatever, item that you're, trying to protect. So. We also make a GFCI with night lights in them, and those are built in. They've got a sensor built into the device, so at nighttime that light automatically is going to come on, so that when you go into a dark bathroom, you're going to have some, some egress lighting. So they're pretty bright, and they do their job. This was an item that we talked about. I think right before the meeting is what happens if you have a GFCI receptacle on an area that is not that's unattended, like a sump pump, or it's behind in a refrigerator and it trips and you don't know about it. This is basically an audible GFCI. It will beep and till you reset it. So. And same thing, when all of our devices, you can see at the bottom right, we've got the LED light. These are all self-test devices. When they're at end of life, you'll see a red light. You won't be able to reset it. It's time to, obviously change that out. And last, yep.
Dave, on that audible one, if you're not home, there's nothing like Wi-Fi, nothing that goes to your phone. Do they make a device to let you know on those? Like just in case the refrigerator goes and you're away?
So, unfortunately, not remotely to the outside. The only way that you're able to detect that is through a circuit breaker. You can gain that function through that. And I've got a section kind of later on in the presentation that talks about that stuff. So, and then lastly, our GFCI with USB charging. And this seems to be the most common one because it's got the old Type A USB and then the new Type C USB, which is all the new devices that you buy are basically the Type C. I kind of got into, I wanted to throw that slide in there. I wanted to talk about tamper resistant. I think I drove that point home. So we've got tamper resistant in GFCIs, regular receptacles. This is a good device for like hallways and stuff like that. So it's got a built-in night light with the receptacle underneath it as well. In our AFC lineup, same thing. We have a 15 amp tamper resistant 20 amp version, both standard AFCI. We have a blank face as well, and then we have a blank face with a switch. So in the case that you needed to switch something, you've got that kind of built in. Leviton was also the first manufacturer that basically combined an arc fault device and a GFCI device together in one. And so we basically got that out in the market as well. And you've got to wire up.
When you if I put a GFI tester inside arc fault, it trips it just by shoving it in, I find.
No. I got a great tool that I carry around, and I'm gonna kind of, there it is. So this is probably the best as an inspector. I have one personally because I go in houses and I have to troubleshoot stuff. It's a Klein RT310. It tests both GFCI and AFCI devices, and there's a separate button on the device. A GFCI, that little plug-in tester that you've got, it doesn't replicate what's needed to trip an AFCI. So it's a whole different, device, and that's why I recommend this unit here. So good question. I had it locked and loaded. This is another one that's in the code that came up. And again, it makes perfect common sense, but it's it's definitely a safety thing. So what the code is under 210.70 saying that any detached garage or an attached building basically needs to have, and they basically say if the structure has no power in it, you don't have to do anything to it, but if it does, it basically wants lighting outlets within the area. So a perfect example is on the back of a house is a bulkhead door. If that door from bottom to top is greater than 5 feet and has more than 6 stairs, the code basically requires that you put a light, in that area. So, and it makes good sense. I have a bulkhead. I have no light. And every time I open up to try to go out, it's a to-do. The other thing that came into the 2020 code, which is now required on new homes, is surge protection. So we talked about GFCI protection, personal protection, AFCI, personal protection. Surge is another thing to really protect equipment and appliances in your home. So the code basically says if you build a house, it must have whole home surge built into it. And basically this kind of just, kind of showing a diagram of your power coming in, your feet are going out, and basically saying after you get, past this point, you need to start introducing surge protection. They really want whole home surge is what the code inspectors are looking for. So when you get into surge protective devices, they basically break it down into categories of type 1, 2, and a type 3. Type 1 is an actual circuit breaker that is a whole home surge breaker. Type 2 is a unit that you can actually wire into your load center. And then type 3 is basically receptacles that are surge receptacles, or the plug-in strips. But when you get to code, the inspectors are really looking for type 1 and type 2 surge in the home. It might be something to recommend to people because with everything being electronic, there's more problems with noise and surges that are coming into the house causing problems, and this will kind of dovetail into that microwave situation when we get to it. The other thing that within code under 225.401 is basically any new house needs to have an emergency disconnect, single and two family homes. So basically, if you're in a house, that's fine. But as soon as you change something out on the outside of the house, you need to now have an emergency disconnect. The real purpose of that is if there's an emergency at your home, there's a fire, instead of the fire company coming up and cutting wires and stuff like that, they want to be able to shut your house off from the outside. And that's kind of really what's, driving that.
Kind of like condos. All condos have all the disconnects, outside.
Yeah, absolutely. So
residential now.
You guys probably already seen it, and obviously the code, they're putting it in to try to really drive it and force it, force us home. And then I had some of this on the code regarding swimming pools, and really what this is doing is it's taking again 15 amp 20 amp devices, 120 volt, and they're really pushing the code to now go after things that are 240 volt, and higher, up to 60 amps and less. So what they talk about in this article is an SP GFCI. So that's a special purpose GFCI device. And back in the beginning, when we were talking about GFCIs, I talked about a UL 943A devices that at 5 milliamps. A special purpose GFCI doesn't need to be at 5. It can be at 20 milliamp. And they basically call that a UL 943 C device for special purpose GFCI. But again, the code and the requirements, they're not stopping. They're just growing. And this talks about if you have a shed or some type of a dressing room at a pool, it's required to have GFCI protection in that I guess building as such. And then this talks about under this code article about 250 volt receptacles. So sometimes you'll have heaters and other devices that are 240 volt powered, and now those need to be GFCI protected. Now I'm going to kind of slide into the load centers, and we got into this business back in 2018, and the reason why was the GFCI receptacles, which have been around for a long time. Leviton had started to see sales decline on GFCI receptacles because when you were building a new house or somebody was making an upgrade, they chose rather to protect those circuits from devices, receptacles in the wall. They wanted to protect them from the load center, from the panel. So we entered this market back in 2018. We probably have got the one of the safest panels on the market. We know it's that good because all the competition is trying to catch up and put features that we have in our existing panels into their new lineup. So we basically single phase panels. We go from 20 circuit all the way up to 66 circuit in the home. This top right item is a surge breaker. I don't know if you can see it, but right at the bottom there's a little lightning bolt that kind of just tells you that that's a surge breaker. So you can easily detect it when it's in the panel over here by looking at the at the little I guess symbol on the bottom. Now on these bottom breakers, these look like dual functions because there's two lights, a single GFCI or a single AFCI circuit breaker will have one light on it, and the two light units are usually dual function or combination breakers. But next to the light, there'll be a little symbol that'll say like AF for rock fault or GF for ground fault. So it's really easy to detect, what that breaker is. Just yesterday, Leviton, we basically had smart breakers, but yesterday we just launched our Generation 2 smart breaker, which basically can fit in any panel that's out in the market right now from when we started making them back in 2018. And basically, where we're getting to is as the country or as the effort is to electrify everything with like electric heat pumps, EV chargers, and stuff like that. It's forcing more power that maybe you don't have in your home, and you've got two options. One, you increase the service at your house. So if you have a 200 amp service, if you got a big house, you may be forced to upgrade to a 400 amp service. Or the other option that you have is manage the power in your house. And basically this is the solution that we're basically rolling out. So the second generation smart breakers are paired up through an app. We basically have the full breadth of breakers, AFCI, GFCI, single pole, 120 volt, two pole, 240 volt. And then those breakers basically tie into an app. So if you had a GFCI breaker tripping your panel, you will be notified on your phone, what circuit tripped and what caused the circuit to trip.
Hey, Dave.
Yeah.
On the surge breakers, does that turn off power to the whole panel? On the master surge?
So on the surge breaker, if basically what its device is, it won't turn off power in the panel. It will basically, the surge breaker will take a hit. When the surge breaker no longer is protecting your panel, it will go into it has an LED on it as well, and it will tell you that it's at the end of life.
Okay.
So the surge really never does anything. It's just basically protecting the panel from a potential surge.
It's taking the damage.
Yes, absolutely. Yeah.
Okay,
and when it's no longer doing its job, it'll notify you. So on our second generation breakers, we can now from the app, I can go into a breaker. I can actually turn that breaker on and off from my phone in the panel. I can actually go into the panel and actually set up a schedule inside the panel. So if I had an irrigation system or if I had a pool, maybe that pool shed that I was protecting on a GFCI circuit, I could go in there and say, hey, listen, I want to shut power off in that panel from dusk to dawn. I don't want any power going off into that shed in there. I can actually set a schedule inside the circuit breaker, really eliminating a time clock. Back in the day, that's how you used to have to control things through a time clock. But now technology allows us to do it right within the circuit breaker. Also within this Generation 2 launch that we had. Oh, here's a perfect example. On the circuit breakers, you can basically see that there's a GF, AF, GF. So those, and then way at the bottom, you'll see an off light. So on our smart breakers, if I turn the breaker off from my phone, that light will actually light up so that if anybody's looking at the panel, they'll know that somebody turned that breaker off, remotely from the phone. But sliding over to the left, we basically have a hub that basically talks to these smart breakers and basically talks to your Wi-Fi and then just connects up to your Wi-Fi in your home. We include like 3 sets of CTs that you can actually buy and plug into the hub if you wanted to detect what your load consumption in your panel is. You can actually put those CTs on the main conductors. If I had solar on my roof and I wanted to measure my solar generation, I can actually put a set of CTs on my incoming solar, and right from my phone, I thought I had this slide gets in and talks about the scheduling of the internal breaker. Here's where I was going to. If with those CTs on there, based on that app, you can basically see what's being created by solar off to the left and what's coming off to the grid on the right to power my home, which is I think that's 4,000 watts. So right from your phone, you're able to drill in, know where your power is coming from. If you want to see circuits individually, these smart breakers, I can actually go in and look at what that circuit is actually drawing that's on that breaker. So I can get an overall, 1,000 foot up view of what's going on in my house, but then I can really drill down to circuits and see what's going on in my house. Where we're going with this is within this app is now I can manage and control power when I want to shut loads off so that, I can not pay for, electricity when it's not needed, and 2, kind of manage my power in my home.
Dave, question for you.
Yeah.
A lot of the boxes that we see are very crowded. And one of the questions here is, we see old surge protectors double tapped into breakers. With all this stuff coming in with these surge protectors and energy data, can this stuff be double tapped?
So what's unique about our breakers is we don't actually have lugs on our breakers, so you really can't double tap our breakers. But I guess to answer that question, really, when the surge goes into your house, you should have that on a dedicated breaker. Probably the reason why somebody double tapped it and shared it with another breaker is they didn't have maybe enough room in the panel, but they wanted to add surge so that it would do some protection. I don't know if the result of sharing it on another breaker is probably the best thing. Will the surge be doing what it is intended to do or not?
Gotcha. Thank you.
But they should be on dedicated circuits.
My understanding is everything should be on a dedicated circuit. No double.
Yeah. And basically with this load center that we've got, and from this app, I can not only monitor my panel from this app, I can manage lighting controls. So when people want to start getting into home automation and they want to have lighting on at a certain time, or they want to come home and hit a button and a scene comes on, that's done within that same app. And Leviton also makes EV chargers, and we have Wi-Fi EV chargers that connect into the same app, so I can get alerts based on my car, where is it? It's 80% charged, and and I can get and I can actually get alert once it's fully charged. I can go out and shut that off as well.
Gotcha.
These breakers, Dave, will let you know if you have a trip on a sump pump, right?
Yep. So if I had a GFCI circuit breaker on a sump pump, and that sump pump tripped that breaker, I would get an alert on my phone, And when you set this up in the app, you can actually go in and name the breaker, so you can actually you can name it sump pump, so you'll know, what the circuit is. And before I get into the communications, I want to go back and I want to talk about that question about the AFCI, GFCI, and the tripping and stuff like that. What we found out, and for the most part, I'm not saying it's 100%, but I'll say it's 90%, is the equipment that's being installed in houses is doing its job. The first thing that happens when somebody goes to buy their microwave and they open their door, and actually this same thing happened to somebody in our company. They installed the Leviton load center. They were having an issue with their microwave unit, and it was like anytime they turned that door open and the light turned on, it would trip the circuit, and he didn't know what it was. We're able to go in and look at the last 20 trips on our circuit breaker. So when they saw that, they said, yeah, something isn't going, something's not right on your microwave. When he went back to the place that he bought it, he found out that there was a recall on the microwave, and the dealer of the microwave actually had a kit that he needed to go and install in the microwave to fix a problem that they had. I just experienced a condo development that I went in a couple weeks ago, and I just got the information back yesterday on it. We had a situation where a kitchen refrigerator on a dedicated circuit, it was an AFCI or a dual function AFCI GFCI circuit breaker, and it was tripping out on some of the homeowners. We sent those breakers back. They analyzed them. I got the information back yesterday. The actual brand new refrigerator was creating a ground fault inside the refrigerator. There was a grounding problem in the appliance, and I shared that information back, to the contractor, and so a lot of times you think, the problem's in the, I just installed this panel. I never had that problem before. It's going to be it's going to be a breaker. It's going to be the receptacle. And really what you find out, it's something else. But
we had a question here on all this technology. Can the breakers be manually overridden if the app gets a virus or your phone goes dead, you're not able to access anything?
So with our breakers, so I guess first of all, if I lose internet in my home, obviously it breaks the connection off to my app on my phone. I no longer can look inside my home because I don't have internet. But as long as I got power in the home, anything that I've programmed into the breaker or schedule, anything will continue to work because that program resides on the breaker and not on the app. If your phone gets a virus, there is no risk of that ever getting back into the panel or the app, really, for any part. We haven't uncovered anything like that where somebody can take over, either take over your house or
tripping your GFIs.
Starts tripping breakers in your house and stuff like that. So
thank you.
I mean, from the app, you can invite people, to be able to have access to your house. That control is in there. But most of what we're seeing on the AFCI side of things is noise, and noise is causing a lot of nuisance tripping on the AFCI side of things. One of the things that we're able to do, because we have technology built in our circuit breaker, is we actually have a chip inside the breaker. We can actually go in and update the firmware on the circuit breaker to ignore certain noises that were causing that breaker to trip. So Leviton, I think we're really the only manufacturer out there that can do that. Is we can help, and I've done it at many properties throughout Connecticut. Is when we've run into those situations, I can actually kind of get it fixed for you. So, but the problem really comes down to there is noise in the house, and clean power. And a lot of times it's the appliances that cause the problem. I brought up this last section because as you guys are inspecting houses, in the code, they're really they got a new article on communication cables and grounding communication cables, because it can create noise in the house if it's not properly grounded. So it talks about certain cable clamps to use, what's good, what's bad, these little clips that you usually see like on cable, RG6 cable, for coax and stuff like that. It's a bad connector to use, but everybody uses it. So, but if the system isn't grounded right, you can create noise in your house. You can create some of the problems that I think we're going to encounter more and more as code drives us to these more sophisticated, devices and stuff like that. So, so it's unfortunate. So I got a couple landing pages here that if somebody wanted to, go up and check anything on AFCI safety products, protection products. And then down in the bottom here, we basically have an app that's basically free to download on your phone. It just talks about, current codes. So if you're running into something and you're interested in knowing a little bit more about it, we provide that, free of charge, and we keep it updated as the code changes every 3 years. So,
guys, I'll post that on the website later.
Dave, on those combination breakers, are there two? If it's a GFI arc fault combination, is there two separate resets, or one reset?
One reset on the combination breaker. So if your breaker trips, once it trips, one of those lights are going to light up. It's either going to be the AFCI light or it's going to be the GFCI light. That will tell you what caused the fault for that breaker to trip in the first place. If that happened to be a smart breaker, you would get that same information back on your phone, and it would tell you, what caused that circuit breaker to trip. So.
That's your breakers, or is that the same with Square D, GE, and all those?
That's just us. So just recently, Eaton and Square D launched a smart breaker product. Square D only did it with their I want to call it their premier panel, which is the QO panel. And Eaton did it with their lower end panel, which was the BR series panel. And they created a smart module that you use in conjunction with your circuit breaker to be able to get it to talk to a external app on your phone. The only problem is in Eaton, if you go back and you look at my single pole smart breaker, here's a combination arc fault, ground fault smart breaker. Mine's all built within a single pole package, which it was, this is a 120 volt breaker. Eaton basically made it a 2-pole breaker. So their second pole that's next to this doesn't have a handle on it, but it's where they keep all the technology to be able to talk to their version of the app. So unfortunately, in an Eaton panel, when you start putting in smart breakers, you're going to lose a space for every smart breaker that you put in. So, and Square D kind of did the same thing. They made a module that will plug in next to the breaker to be able to get that breaker to, pull the information out and communicate with an app. So in the Square D panel, you're going to lose a spot as well.
Question on arc fault circuit interrupter. So you're in a living room, you get a question from a client. I have a 2-prong outlet. If they can, and there's no ground, if you connect that wire to an arc fault, is that the same protection as if you would put a GFCI there?
No. So there is I don't have the information in front of me, but I could certainly get it for you. In older homes, when they only had 2-wire devices, there's a way that you can introduce, and basically what you do is you introduce a GFCI receptacle, and you can kind of create a ground within your wiring within a house via utilizing a GFCI receptacle. There's a way to do it. I've run into them, but off the top of my head, I kind of forget, the wiring schematic to do that. But
you
I
should
bet
be able to bond it right to the box, and then the box becomes the ground or the bond back to the panel. Because
if it's a metal box,
the old BX, and it's still bond, 2-prong is still grounded. It's just the appliance ground is not grounded, which would be on a 3-prong.
Yeah. So like, you're right, because there are some people that, if you had BX running through the house, you had a metal box, they've taken out the 2-wire, maybe attached a wire to the back of the box, and created that ground and you can actually get a ground that way. So as long as you have a continuous ground, you're okay. But in some cases, you're in a house that they didn't use BX, and now you don't have a continuous ground. You can actually create a ground by wiring in a GFCI device a certain way, and actually create a ground, which is pretty interesting. So,
are there any other questions? This was very, very informative tonight.
That was awesome. Thanks, David. Really appreciate it.
Sure.
And we can, if any of our members, had some questions, they could certainly, they could reach out to you if they had a question on an inspection or something wasn't right. They could certainly text you, call you. Are you okay with that?
Absolutely. Yep. You can send me an email, and I usually respond right away.
Well, thank you very much, Dave. I'm going to end the seminar now, and please join us in 2 weeks for air admittance valves. Thank you.